Hello students, in this lecture video we are going to discuss analysis of variance, its assumptions and performing one-way analysis of variance using SPSS. So first of all, the assumptions of analysis of variance are independent samples, normal populations and equal variances. Now how do we identify that the given data set is based upon independent samples? To understand this, I have considered this question 15.34, that is, for the chain of convenience stores wanted to test three different advertising policies in terms of their effects. Policy 1, no advertising. Policy 2, advertise in neighborhood with circulars. And policy 3, use circulars and advertise in newspapers. For this purpose, what they have done, they have selected 18 stores randomly and divided them randomly into three groups of 6 each. And each group used one of the three policies. So first group of 6 stores is asked to follow the policy of no advertising, which is policy 1. Second group of 6 stores have followed the policy 2, which is based upon advertising neighborhoods with circulars. And the last set of 6 stores followed policy 3, which is using circulars and advertising in newspapers, both the options. So what they have done later on, they have recorded the sales amount on the basis of three policies in all 18 stores, grouped in three different locations, or you can call it different sets. So now how can we identify whether the given sets of data sets or samples are independent samples? To understand this, we need to look at the data. 6 stores have followed the policy 1. 6 stores have followed policy 2 and 6 stores have followed policy 3. And over there the case is the number of stores who have followed which have followed policy 1 did not follow policy 2 or policy 3. The stores on which policy 2 is implemented, policy 1 and policy 3 are not implemented, and the stores on which policy 3 have been implemented or followed, so on those stores policy 1 and policy 2 are not followed. So therefore the samples are independent samples because each set of 6 stores have followed a different policy, and they have not observed any sales on the basis of the other two policies that are structured. So independent samples, this is how we identify after reading the question carefully how the data are collected. If this was the case, as all 318 stores were randomly selected, and then they, instead of dividing them into three groups, all 18 stores have experienced policy 1 for the first month, then policy 2 for the second month, and then policy 3 for the third month, and their sales data have been collected in this way. In that case, since all 18 stores have got the exposure of all three policies, therefore we call the samples the dependent samples. Okay, so this is how we differentiate between independent and independent samples. Now I'm going to create the file for this data. So how can we create the file for this data? First of all, we will create two variables. One is policy and another variable is sales. And variable, and since policy variable is qualitative in nature, it has three categories, so therefore we are going to assign codes to these different policy structures. So policy 1 represent. Policy 2 should be coded with 2, and policy 3 should be coded with 3. And if we look at the data, 6 stores have followed policy 1, so we need to enter 1 6 times and 2 6 times, and then 3 6 times. Okay, now I'm going to enter the values that we are given in the data. That's 22, 20, 26. Then we have 21, 24, 22. Then 21, 25, 25. 20, 22, 26. 29, 24, 31. 32, 26, and 27. So this is how we have entered the data. First of all, as usual, we go for exploring the variable, and initially we can develop the opinion about the difference for the entire population in terms of mean sales. If there is a significant difference between the mean sales on the basis of 3 different advertising policies being followed by 18 different stores. So we need to first get this idea on the basis of exploring the sample data. And this is how I've used the path as analyze, descriptive statistics, and explore. Now we take sales as a dependent list variable, policy as a factor list variable, and what we need to go for is the normal test side by side for all three groups, so that the second assumption, important, third as important as a second assumption of normal populations we can assess. Okay. Now we go for paste, then run, and this is how we get the output of explore. Over here we can directly go to the last graph, that is the box plot, and we follow the rule of extending the central line of each box in the box plot and check whether this central line is overlapping in any other box or not. So this we can see as easily as that the central line of the first box is overlapping in another box in the second box, and the central line of the second box is also overlapping in the first box. But as far as third box is concerned, the central line of the third box is not overlapping in the other two boxes. So there is a possibility that the means will not be significantly different, or mean sales will not be significantly different on the basis of policy 1 and policy 2, but policy 3 has significantly higher sales amounts on the average. You can see its location and its non-overlap behavior with other two boxes. The central line is non-overlapping with other two boxes, is telling us that there is a possibility that the policy 3 is the most effective policy. So this is what the sample has guided us. Similarly, we can go and check for normality as well. So we have performed normality test already, and we can see the significance associated to each policy whether it is Kolmogorov-Smirnov or Shapiro-Wilk test. In both the cases, all the datasets, all the policies qualify normality tests. So we can comfortably go for a parametric analysis of variance. We need not to go for non-parametric test. Now, what we do, we in the next step, we will perform one-way analysis of variance using this path, analyze, compare means, one-way ANOVA. Sales we take as dependent list variable, policy we take as factor list, and we go for post-hoc. In post-hoc, from the second column list of options, we mark a check across Stucky. That gives us Stucky multiple comparison, because in case when the null hypothesis of analysis of variance is rejected, in that case we have to check which pairs of means are responsible for the rejection of the null hypothesis. And we click on options, we can mark a check across homogeneity of variance test. That's the third assumption of analysis of variance. Now paste, and we go for the output. Now the very first table in this output is test of homogeneity of variance. And how can we perform hypothesis testing for this? So I'm changing the page. Over there I'm going to write down the testing of analysis of variance. As the first part, we are going for equality of variance test. Over here, the null hypothesis we can simply state as the variance of the sales generated on the basis of policy 1 equals variance of sales on the basis of policy 2 equals variance of sales on the basis of policy 3. So there is no significant difference in variability of sales on based upon three policies. Variability in sales of all three policies. Over here, instead of writing down the three variances with not equal sign, we will write it down as at least two variances differ. Because H naught is one rigid situation in which all the variances must be equal, and if we state H1 as or with similar rigidity as not equal to sign but among all three variances, therefore it is again another rigid situation, because there may be a possibility that that one pair of variances may be equal, the other two may not be equal. So even in that situation, H naught will be challenged if even if one pair of variance differ. That's why We state it as at least two variances differ. Now we have level of significance of 0.05. Then we have test statistic, that's Levine statistic, that we are given. And then we write down decision criterion as the condition under which H naught would be rejected. So H naught would be rejected if p-value p-value corresponding to Levine's statistic is low or is less than 0.05 at least. Now we write down decision and conclusion accordingly. After looking at the results in the table. So the significance or p-value associated with Levine statistic is not less than 0.05. Therefore, H naught is not rejected, would be our decision. Since p-value associated with Levine's statistic is not less than 0.05. Therefore, H naught is not rejected, and consequently it cannot be concluded that at least two variances differ or not all the variances are equal. Or over here, since equality exists, therefore that the variances differ may be a sufficient argument. So this is how we perform equality of variance test. Now we need to go for equality of mean testing. That's the purpose of ANOVA. Equality of more than two means. Over here, in terms of notation, we can say that the mean sales generated on the basis of three policies are equal, or there is no significant effect of advertising policies on mean sales. Alternative hypothesis. We need not to write down with not equal to sign. The reason we have just discussed in case of equality of variance test, that this is again a very rigid situation. There is something in between the two situations that may exist. That if a single pair of mean is unequal or goes unequal, H naught will be rejected even in that case. So therefore, preferably we either write down it in at least in terms of at least two means differ, similar to the previous case in which we have written down or stated our H1 as at least two variances differ. We are now writing down as at least two means differ. It covers all possibilities. And in terms of a qualitative statement that is reflecting the question that we are dealing with, there is a significant effect of advertising policies on mean sales. Level of significance alpha equals 0.05. In the question it is given as 0.01, so we can take it as 0.01 instead. Test statistic is F, that you can see in this table. The ANOVA table is computing F, that is based upon mean squared between groups, mean squared within groups, that we can alternatively call between treatments and within treatments, or between treatments and error, or treatment sum of square or error sum of square, that makes total sum of square when we add these two together. Now we write down decision criterion in terms of p-value, same as before, as the condition under which H naught would be rejected. H naught would be rejected if significance or p-value associated with F statistic, because we are performing this test on the basis of F statistic, is less than 0.05 or very low. The closer it would be to 0, the stronger would be the case of rejection. Now, decision and conclusion. Since p-value associated with F statistic is less than 0.05, therefore H naught is rejected, and it can be concluded that at least two means differ, or there is a significant effect of advertising policies on main sales. So based upon the rejection, we can develop an argument in line with our alternative hypothesis, or in favor of alternative hypothesis. So this is how we perform one-way analysis, but it is not ending up here. Rather, we need to make comment on the pair of means that are maybe different or are responsible for the rejection of H0. And for that reason, we have marked a check across post-hoc test and HSD, the key HSD as a post-hoc. Over here, we need to look at the results pairwise. First of all, we will compare the mean difference, whether mean difference of the two different advertising policies differ or not. So we first consider pair 1 or policy 1 with policy 2 stated or mentioned as pair 1 in this table. Looking at significance, it is found that it is not statistically significant. So mu1 may not be different from mu2 or not significantly different from mu2. Therefore, H0 is not rejected. H0 of equality of two means we are performing here. So there are three pairs that must be studied: 1 versus 2, 1 versus 3, and 2 versus 3. So 1 versus 2 is not found significant. 1 versus 3 is found significant because this significance is well below 0.05 that we usually use as a yardstick for high cost testing. Now, whenever we found a difference, we need to look at the sign of the mean difference immediately. So sign of mean difference is minus, and minus indicate that we are comparing this policy 1 and policy 2 difference. So we can state it as mu1 minus mu2 comes up mu1 minus mu3 comes up negative, and it can be deduced as mu1 is less than mu3. Does indicate that mean sales generated on the basis of policy 3 is significantly greater or higher as compared to policy 1. Similarly, if we look at the outcome of the third pair, policy 2 versus policy 3 comparison, again this is also significant at 0.012 significance level, that is less than 0.05. Therefore, H0 is rejected. H0 of equality of two means is also rejected in this case when we compare policy 1, policy 2 with policy 3 results. Now again we look at the sign. Sign is again coming up negative. Therefore, let's mu2 minus mu3 is again coming up negative. So it implies that mu2 is less than mu3. That can be considered as the mean sales generated on the basis of policy 2 are significantly less than that of policy 3, or vice versa. So furthermore, if we look at this homogeneous subset table generated on the basis of Tucky HSD again, so we can see that the two policies for which we have not found significant differences between the mean values are located in the same column. And if we look at the mean values, policy 1 has a mean sales of 22.5, whereas policy 1 has a mean sales of 22.5, whereas policy 2 has a mean sales of 23.167. So not a significant difference as visible over here if we compare the two values together. But policy 3 has a higher mean sales, that's why the key multiple comparison has segregated that. And if we look at the values, it is strictly following the order. So policy 1 has a least mean sales. Next high mean sales is of policy 2 that are not significantly different from policy 1 mean sales. And the highest mean sales is of policy 3. So finally, we can write down or compile our result in this case. Policy 1 mean sales are nearly equal to policy 2 mean sales. Policy 1 mean sales are significantly different and comes up as mean sales generated on the basis of policy 1 are less than policy 3, and mean sales generated on the basis of policy 2 are again significantly less than mean sales on the basis of policy 3. So that's all for this session.